All right, guys, we're going to finish lesson 9.5 here. So we're going to go back to example 2. And actually, if I go back a page before that, at the bottom, we had noticed how the sine of one angle is equivalent to the cosine of the opposite acute angle, meaning we're talking about a right triangle. So there's only two angles that remain aside from our right triangle, or aside from our right angle. So if we look at this angle, this here, this is my right angle. So there's only two angles that we could be talking about. It's either x or y. So if we know the sine of x, that's equivalent to the cosine of y. If we know the sine of y, that's equivalent to the cosine of x. And that's what they say here. I think it looks a little complicated the way they have it written. But if you want to look at that a little more closely and dig into it, you can understand that, okay? All right, so let's just try it though. We'll see what that means. So in this example, they're saying rewrite trigonometric expressions. So write the sine of 56 in terms of cosine. So if I have a right triangle, this is a right angle, and this is 56 degrees, well then what would my other angle be? Okay, so obviously we know there's 180. We can also just do 90 minus 56. And we find out that this angle here is 34 degrees. Okay, so the sine from this angle is going to be equivalent to the cosine from this angle. And that's really all I have to write. So the sine of 56 degrees is equal to the cosine of 34 degrees. Now I want you to take a minute and type both of those into your calculator. So sine of 56, and I get 0.8290. And if I go ahead and do cosine of 34, cosine of 34, I get 0.8290. So that just reinforces that they are the same thing. And we saw on the other side when actually we tried it with numbers why that works. But we can see it here with our calculator that that's what happens. Okay, similar concept. If I have a right for letter B, if I have a right angled triangle, a right triangle, you have this measurement here, I can go ahead and figure out that my other angle is going to be 21. So the cosine of this 69 is going to equal the sine of 21. And if I want to check it, again, it's simply just typing it in to make sure that it worked. And if I check both of those, I end up getting 0.3584 and then again 0.3584. Both of them are the same value. Okay, so it worked. So there's just an easy kind of relationship between the two. If you don't know, if you know one, you kind of know the other, depending as long as you read it correctly. Okay? All right, we're going to scroll down to examples 4 and 5 and finish up with some real life problems. So we always want to remember how everything connects, which is kind of the cool thing about math. So here they want us to use special right triangles to find the sine or cosine ratio. So they want us to figure out that ratio using what we know about special right triangles. So a special right triangle to find the cosine of a 45 degree angle. All right, so let's go back to a 45, 45, 90 right triangle. If this is the case, we know that this is x, and this is x times the square root of 2. All right, so let's call this angle A, okay, but it's 45 degrees, we know that. So I'm going to go ahead and find the sine of a 45 degree angle. Okay, now you could type it in your calculator, and right now I'm going to get, if I put that in, 0.7071. Let's see where that comes from. So sine from 45 degrees, in this case, is going to be my opposite side, which is x, over my hypotenuse, which is x times the square root of 2. Now, if you had wanted to put numbers in for x, you could, but nonetheless, what's going to happen to these x's? They are going to cancel out. So I'm left with 1 over the square root of 2. We don't like leaving it like that, but if you put 1 divided by the square root of 2 in your calculator, you'll get the same decimal, 0.0701. Or I would multiply this by square root of 2 over square root of 2. Do you remember what that's called? Yes, very good. Rationalizing the denominator. So the answer here is square root of 2 over 2. Okay? So we're using your special right triangles to find a sine or cosine ratio. Okay, so the ratio there is square root of 2 over 2. Let's try it with a, oh, we didn't do find the sine and cosine. So we know that cosine is the same as, so if we know the sine of angle A, it's going to be the same as the cosine, I call that, of angle B. Well, in angle B, it's 45 degrees. So cosine of angle B, if I go ahead and type in cosine of 45 degrees, I get the same thing. Okay? All right, so they're both sine of 45 and cosine of 45 equal the same thing. All right, let's look at the next one. So special right triangle to find the sine and cosine of a 30, 60, 90. This one's just a 30 degrees, so I'll take it from this angle. They say from angle 30 degrees. So if I'm going ahead to find the sine of, first let's fill in our ratios. So this is x, this is 2x, and this is x times the square root of 3. So the sine from a 30-degree angle is going to equal x over the hypotenuse 2x. My x's cancel and I get 1 over 2. All right, let's try the cosine from a 30-degree angle, and it's going to be adjacent, which is x times the square root of 3, over hypotenuse 2x. So my x's cancel and I get square root of 3 over 2. All right, now these two relate because now they want us to go ahead and find use a special right triangle to find the sine and cosine of a 60-degree angle. So same setup, 30, 60, 90. This is x, 2x, and x times the square root of 3. Okay, so now if I want the sine from a 60-degree angle, that's down here. So my opposite side is x square root of 3. My hypotenuse is 2x. My x's cancel and I get square root of 3 over 2. Isn't that interesting? That's what we saw down here. So that matches what we learned up above. All right, the cosine of 60 degrees is equal to adjacent x over hypotenuse 2x. And same deal. That's what we saw up above as well. That relates there. Okay. There are some of these in homework. I'm not asking you any of this lesson, this portion of the lesson, but I wanted to show you how you can use special right triangles, how things connect. All right, but let's get into some applications to finish it up. When looking up at an object, so real life problems, the angle your line of sight makes with the horizontal line is called the angle of elevation. So that means here's me, okay, and I see a bird flying in the sky, okay. I'm going to, this is the horizontal line of my eyesight. This is where I look up to see the bird. This is called my angle of elevation. Okay, so angle, how high I look up. Now, the next one is called an angle of depression. This is when we look down. So when looking down at an object, okay, so I'm looking down at an object, in this case, the angle your line of sight makes with the horizontal line is called your angle of depression. So maybe I'm standing on, a cliff and I'm looking down something. So this is here is my angle of depression. Okay, let's try some. On the next page, they're going to give us 3 problems we're going to work through. So in example 6, letter A, it says you lean a 16-foot ladder against the wall. Now, if the ladder makes an angle of 70 degrees with the ground, how far away from the wall is the base of the ladder? So here's my ladder. It makes a 70-degree angle. How far away from the wall is the base of the ladder? That's what they want us to figure out, how far away it is. So in my triangle that I'm working with here, I know the hypotenuse. The other thing I'm trying to figure out is this distance. So I need to figure out which trig function lets me use that. I have the hypotenuse, it's hard to read that, and I have this side, which from a 70-degree angle is my adjacent side. So, writing over that, I have those pieces. So which trig function uses hypotenuse and adjacent? That's going to be cosine. So I'm going to say the cosine from a 70-degree angle is going to equal, I called this x over 16. Multiply both sides by 16.
those cancel, x comes down, and I get 16 times the cosine of 70, 5 point, it doesn't say how much rounded to, we'll say 10th like we normally do, 5.5 feet. So this is about 5.5 feet away from the wall. Okay? All right, so really we're just using our trig functions, but they're giving us a background of a house and a ladder. All right, let's see what we have in the next one, a roller coaster. So you're at the top of a roller coaster, 100 feet above the ground. So here's where you are. You are 100 feet above the ground. This is 100. The angle of depression is 44 degrees. So you're sitting, envision yourself, you're sitting in this little, car, you're ready to go down. You look out, this would be your straight across, it's kind of like your zero marking. You look down at the bottom of the hill, and that's a 44-degree angle. That's your angle of depression. Now, how far do you ride down the hill? They want to know how far is this hill. Now, you happen to know that you're looking down at a 44-degree angle. You're pretty impressive. But let's redraw the triangle. Oops, sorry. Okay, so we're going to redraw this triangle here. I'm going to use the markings they gave. Okay, so I'm working with the triangle that's given. So this is 44 degrees. This is 100. And this is what I'm trying to find. All right, so from my 44-degree angle, the x is obviously my hypotenuse. So in this problem, I'm given the hypotenuse. Well, I'm not given it, but I need to find it. So that's one of the elements of the triangle I'm looking at. And then this side over here is given, and from this angle, that is my opposite side. So what trig function uses opposite and hypotenuse? That's going to be sine. So I'm going to do the sine of 44 equals 100 over x. Now, if you remember our trick from a lesson or two ago, we said that really when you're given a scenario where this is in the denominator, you can just flip-flop these. So x equals 100 over sine of 44. If you don't like that, you can actually multiply both sides by x and divide by sine of 44. But in the end, 100 divided by the sine of 44 degrees is equal to 143.95, which is going to round up to 144 feet. So you are traveling down this hill about 144 feet. Now that might not be exact because it's probably not straight, but that's a general approximation. Okay? Alrighty, we have one problem left. Before I go on to that one more problem, you could have done this same triangle scenario, but used this portion, in which case this angle here would have been 46 degrees. And you could have said, well, I know that this is x, this is 100, and you could have done cosine of 46. And we already know that that's going to give us the same answer. So cosine of 46 equals 100 over x. So, and then worked it out that way. Okay, you would have gotten the same thing in the end. Okay, so let's do our last one. And this one says you're preparing to land an airplane. You were on a straight line approach path that forms 3-degree vertical angle with the runway. So here's our airplane. We're looking straight line approach path. Forms a 3-degree angle with the runway. What is the distance d along this approach path to your touchdown point when you are 500 feet above the ground? Okay, obviously computers and stuff would do this. You can see how critical this is. It's understood though, because important things lie on it. So here's our triangle. This is obviously the angle we're going to work with because it's given. You have the option, you could have filled this one in, but we're just going to work with what's given. Now from this angle, I have my opposite side, which is marked as 500. So I'm working with an opposite side. And I also have my hypotenuse, which is what I'm trying to find. But nonetheless, that's another key element in this problem. So this is going to be the sine trig function. So the sine of 3 degrees is equal to 500 opposite over hypotenuse d. I'm going to multiply both sides by d. Here, I'll just show you the long way. So now I have sine of 3 degrees times d. I could have just done this quick switcheroo. Divide both sides by the sine of 3. Those cancel. So in the end, I get D is equal to 500